Being able to effectively use scientific notation is really key in our class because we use a lot of big numbers and we also use some small numbers sometimes. So we need to be able to do that. Scientific notation is really easy to do. When you write out scientific notation from standard notation, you can only have one number to the left of the decimal. So I'm going to put my decimal, so there's only one place value to the left of it. So I'm going to write down the non-zero numbers, 2.34. I know this is going to have to be a times 10 to some power. The power relates to how many decimal places I moved. Right now, the imaginary decimal is at the end of the number. It moved 3 spots, 6 spots, 7, 8 spots. So there's my power. Now I have to just decide, is this a negative power or a positive power? This number right here was a really big number. I changed it to a small number, 2.34, small relative to this one. So this part of my number, the times 10 to the 8, needs to be big, so I'm taking 2.34, a small number, times a big number makes a big number. Likewise, number 2, one non-zero number to the left of the decimal, so 3.2 times 10 to the 1, 2, 3 spots moved. And I just made a small number a bigger one, so this time I need to take a decimal times a smaller number times 10 to the negative third is small to make a small number. 5.62 times 10 to a small number, 1, 2, 3, 4, 5, 6, 7, negative 7. 6.92 times 10 to the 1, 2, 3, 4, 5, 6 times a big number. 8.96 times 10 to the 1, 2. A big number. 8.96 times basically 100 makes 896. Let me move the camera. Seven times 10. Now I just made a smaller number a bigger number, so I need to multiply a bigger number by a smaller number to make it back small again. I'm going to put a decimal next to the 8.9. Times 10 to the power of, here's 1, 2, 3, 4, 5. 5.43 times 10 to the 1, 2, 3. 1.29 times 10 to the 1, 2, 3 place values 4, 5. Small number times big number makes a big number. 8.41 times 10, 1, 2, 3, 4, negative 4. That's going from standard notation to scientific notation. To do the opposite, going from scientific to standard, we're just going to analyze what this power of 10 means. This is a times 10 to the negative 3. That means I'm taking 4.74 times a small number, which means my standard notation version needs to be a small number. I need to move my decimal left to make this smaller. I need to move it left 3 spaces. 1, 2, 3. So decimal point 0.00474. We like to put a 0 in front to make it nice and tidy. Times 10 to the positive 5. This is a big number, so this number needs to get bigger by moving the decimal 5 spaces. 1 space will be moved to get past the 0. I need to do 4 more after that, so I need to add 4 zeros. 5, 0 with 4 more zeros. There's my answer. 10 to the negative 6 is small. This is going to be a small answer then. 1 spot to the left, there's one of my places. That means I need to add 5 zeros before the 7. Decimal point, 1, 2, 3, 4, 5, 7, 3, 4. 0 to make it tidy. Then 8.9 times 10 to the fourth. 10 to the fourth is a big number. Let me move my camera. 10 to the fourth is a big number, so this number needs to get larger. It needs to get larger by moving 4 spots. 1 spot to get past the 9. I have 3 more spots to move, so add 3 zeros. And then times 10 to the negative second. Negative second is a small number, so I need to make this smaller. To do that, I need to move decimal left 1 spot, 1 more spot for 0. Decimal point 0, 2, 3, 8,